Thank you, Mr. Chairman. Dr. Weaver, I kind of want to pivot off of that just a little bit. Maybe not pivot, just ask some more questions about it because there's several things here at play. Like we all have talked about for the past year about China and the threat as being one of the greatest threats to our country that there is. And I know that they do a good job of AI. And I guess first question is, where do we stand in relationship to China on the AI race, and maybe some quantum computing in there as well?
Yeah, so I'll be honest with you. I'm not an expert on where we stand with China in terms of AI. So I wouldn't really have much to add to the hearing on that. I don't know if any.
Do you think their AI modeling is pretty good? Have you seen any of their forecasting modeling?
I have not. Therefore, I can't
Have
really
any
comment on it.
anybody?
I have not seen their output. I think one thing that I would maybe caution, and I think this is what Dr. Weaver was referring to, is when we hear claims about these models, it's really important to understand, well, how are these models, AI models, verified, and what were they verified against? And until we can see, those data and how that was done, it's very difficult to ascertain how well maybe the Chinese or others are doing. So there really needs to be
Well, I mean,
a
isn't it,
rigorous.
it's easy to verify it after the fact, whether or not it was true or not, right? Whether or not it happened.
But a lot of times in science, when you're doing that verification, you need to know the methodology that was followed, so that methodology can be replicated and make sure that that was done correctly. And from kind of your question about the Chinese, I don't know if they're verifying against 500 millibar height or temperature at the surface or wind speeds in New York, and really having that verification, thorough verification is helpful.
Right. Well, I've been in small business for over 30 years, and just seeing the accelerated advancement of AI, even in the transportation industry, which I'm in, it's just amazing. And I would like to know where NOAA stands and where we stand from a private industry standpoint in the country, because there is a race, and China spends more money than the entire world on quantum technology and quantum computing, and that's in everything, not just defense, not just hacking, and because they want to rule the world one day. Dr. Jacobs, I was walking in, so I'm sorry, we've been kind of running around like crazy here this morning. You were talking about cloud computing. Is NOAA ready for artificial intelligence? And
So right now, they're testing out a couple different AI systems to replicate a lot of what the physics-based models are using, and they're showing a lot of promise. As I was saying earlier, I think the benefit there is you save on computational resources, at least for the operational prediction system, but you still need to generate the training data sets. When it comes to cloud, NOAA's definitely headed in that direction, as well as a lot of the private sector, most of the universities. I think a lot of, at least in the private sector, I don't really know any companies that own their own high-performance computing anymore. They
Right.
pretty much all use commercial cloud. The beauty of commercial cloud is probably more seen in the research and development than it is in the operational, because you buy on demand. You only buy what you need, and when your research needs fluctuate, that's an extremely cost-effective way to do it. Because if you have a series of experiments that you want to test with traditional on-premises high-performance computing, you only have a limited amount of resources, so you run the experiments one at a time. With the commercial cloud option, you can pay for all of these experiments to be run in parallel simultaneously. It costs the same whether you run them all at the same time or one after the other, but the beauty of running them all at the same time is you get the research done faster.
good. Hey, I've got one other question. I know we're down to less than 25 seconds. But Dr. Jacobs, I introduced the Weather Information for Agricultural Act, and I didn't know if you could take just a minute to explain the advances in drought weather modeling and how it can best be used by farmers.
There's a lot of advancements, and actually, there's a lot of work being done on seasonal and subseasonal prediction with AI too, because a lot of it, there are dynamic models that run out to 9 months, but a lot of this is pattern recognition, seasonal patterns like INSO and PDO and things like that. That's actually a really unique spot for AI. So I think there's a lot of advancements being done on those different forecast horizons, and most of the agriculture community, they know exactly how to use the data. They just want to know both what is the prediction and what is the confidence in the prediction.
Right, right. Thank you. Sorry about that, Mr.